Imagine that the moon is already behind you. 4 days ago, it was blocking your view of Earth. Now Earth is growing in the window again. At first, it was a small blue disk. Then it became the size of a coin. Then it took up more and more of the black space ahead. And the closer it gets, the less this feels like coming home. Because between you and the surface of Earth, there is the atmosphere, and you are flying toward it at about 40,000 kilometers per hour. Inside Orion, everyone is back in their suits. The straps are tightened. The seats are set to landing position. Everything is secured. Bags, tablets, tools, food, everything that has been floating around the cabin for the last 10 days now has to be put away. In a few minutes, this small capsule will hit the upper layers of the atmosphere. Outside, the air will begin to compress so hard that plasma will form around the spacecraft. The windows will turn orange, then almost white. Communication with Earth will disappear for a while. Houston will no longer be heard. Only the sound of the spacecraft, the G-force and the heat, trying to get through the only part separating the crew from death. The heat shield. The same type of protection that returned with unexpected damage on the uncrewed Artemis I. It did not fall apart. The capsule splashed down successfully then. But after the flight, engineers saw that the material did not burn away as cleanly as they expected. Parts of the heat shield cracked and broke off in uneven chunks. For Artemis II, NASA did not build a completely new shield. It changed the return trajectory. Now the crew is flying on a different atmospheric entry profile. Less time in the dangerous temperature zone. A more direct descent. More load on the body. At this moment inside Orion, it no longer matters how beautiful the flyby of the moon was. It does not matter how many photos they took. It does not matter that this mission will go down in history. Only one question remains. Will the spacecraft survive the final minutes? To understand how 4 people ended up at this point, we need to go back 10 days to the launch pad in Florida. Launch morning does not begin with the usual coffee, but with isolation. The crew has already been living under a strict routine for several days. Medical checks, sleep, food, control of contact with other people. Before a mission like this, even the simplest cold is not a small thing, but a threat to the schedule, the crew, and the whole program. Reid Wiseman, Victor Glover, Christina Koch, Jeremy Hansen. 4 people who are about to spend almost 10 days inside a capsule, roughly the size of 2 minivans. From the outside, that sounds tolerable. 2 minivans. It does not seem that small. But then you have to imagine that inside, it is not an empty cabin. There are seats, panels, equipment, cables, life support systems, food, water, waste, tools, emergency kits, personal items, suits, and 4 adult people. And none of them can go outside if they simply want to stretch. When they put on the Orion crew survival system, at first glance it looks like a futuristic spacesuit from a movie. In reality, it is bulky, rigid, uncomfortable, definitely not made for beauty. This suit is needed in case the cabin loses pressure during launch or return. You can think of it as a lifeboat, only worn on the body. Before boarding the spacecraft, the crew goes up the tower at pad 39B. This launch pad has a heavy historical shadow. Apollo missions launched from here. Now NASA's new lunar rocket stands here, the Space Launch System. It is taller than the Statue of Liberty. Fueled, it weighs millions of pounds. Under the capsule are 2 huge solid rocket boosters and 4 RS-25 engines, descendants of the engines that flew on the space shuttle for decades. From the outside, it is a rocket. From the inside, if you are sitting at the top, it is a building full of fuel, metal, and force that in a few hours will try to throw you off Earth. The crew takes their seats, commander and pilot in front, 2 mission specialists behind. The seats are positioned so that during acceleration, the G-force passes through the body correctly, and there is the understanding that in a few minutes, this machine will either behave exactly the way it should, or the crew will have only the emergency systems left. The countdown reaches 0. First, The 4 RS-25s ignite. The rocket is still held down on the launch table, but inside the cabin, the sound already changes. The low rumble becomes denser. The vibration passes through the seat and the suit. Then the solid rocket boosters ignite. And here, there is no way back. A liquid engine can be shut down. A solid rocket booster cannot simply be turned off by command like a lamp. Once they start working, the rocket has to leave. The first seconds do not feel like a smooth liftoff. It is more like an enormous force is trying to drag your body through the seat. The chest becomes heavy. It is hard to raise your arms. Every movement requires effort. The G-force rises to about 3G. That means the body feels several times heavier than usual. For a trained astronaut, this is not the limit, but knowing it and feeling it are different things. You can breathe, but breathing is no longer automatic. The body wants to resist the pressure, and the brain has to stay calm, read the data, and listen to commands. The first 2 minutes are the roughest. The solid rocket boosters shake the whole spacecraft. This is not a cinematic camera shake. This is a physical sensation, as if the vibration is not around you, but inside your bones. Then the boosters burn out and separate. The harshness goes away. The spacecraft continues gaining speed on the core stage, and about 8 minutes after launch comes a moment that astronauts often describe as almost unreal. The engines shut down. The pressure disappears. What had just been pressing you into the seat lets go. The strap holds the body, but the arms no longer feel heavy. They begin to float. Small objects, if something is badly secured, move away from the surface and hang in the air. The rocket is no longer pulling downward. The spacecraft is in orbit, and for the first time in the mission, the crew gets a chance to look out the window not as an instrument, but as a border between two worlds. Below them is Earth, not a map, not a globe, not a photo from Pinterest. The first hours after reaching orbit look less dramatic than the launch. The crew checks communication, navigation, temperature, pressure, and other life support systems of the spacecraft. When the checks are complete, the mission approaches its first real turning point, translunar injection, the maneuver after which Artemis II stops being a flight around Earth. The upper stage accelerates the spacecraft onto a trajectory toward the Moon, and Earth becomes the place behind it. There is a psychological boundary that is hard to show on a diagram. While you are in Earth orbit, home is still nearby. You are flying fast, but around the planet. Continents are below you. Communication is almost instant. Down there are airfields, oceans, ships, people. After the maneuver toward the Moon, everything changes. The spacecraft begins to move away. Not sharply, not like in Star Wars where the stars turn into streaks. It simply moves along a trajectory where Earth becomes smaller with every hour. And now begins the part of the mission that viewers, for some reason, often imagine too romantically: life inside Orion. From the outside, Artemis II looks like a great lunar mission. From the inside, it is 4 people locked inside a machine that cannot be aired out, cannot be left, and cannot be made more spacious. After entering weightlessness, the crew reconfigures the cabin. Some parts of the seats are removed. Equipment is packed in a way that frees up more space. The toilet is under the floor near the main hatch. Urine is collected by the system and vented outside. Solid waste is packed and stored until return. This is not the part of space they show on posters, because real space is not some cool view of the Moon. Space is when you eat, sleep, wash, work, and go to the toilet inside one closed volume, while outside the wall, there is vacuum. One of the strongest contrasts of Artemis II is exactly this. People are flying farther than almost anyone in history. Many ask the same question. If people have already been to the Moon, why does Artemis II only fly around it? This is a crude test flight. Before sending people back to the surface of the Moon, NASA has to prove that Orion can safely carry a crew to lunar distance and bring them back. The uncrewed Artemis I has already flown, but an empty capsule and a capsule with people are different missions. Artemis II is not an attempt to repeat Apollo 11. It is a test of the door that the next missions must pass through. After several days, the moon begins to grow in the window. The gray disk becomes more detailed. Craters, shadows, and unevenness of the surface appear. What from Earth looks like a familiar bright circle turns into another world. But the main psychological blow may come not from the moon, but from Earth. When Apollo astronauts looked back, they described a feeling that later became known as the overview effect. The planet looks whole, fragile, lonely. With Artemis II, the effect may be even stronger, because the crew will go farther than almost all humans before them. At some point, Earth will be possible to cover with your thumb. Everything you know fits behind one small movement of your hand. You are near the moon, and Earth has become an object in the sky. And here, for the first time, the mission stops being only engineering. It becomes an experience almost impossible to explain to someone who has not seen it with their own eyes. When Orion passes behind the moon, the crew sees the side that an ordinary person from Earth will never see directly. It is not the dark side in the literal sense. The sun lights it too. But it is hidden from us because the moon always faces Earth with the same side. The far side looks different. How do they survive radiation? They do not avoid it completely. They manage the risk. While the spacecraft is near Earth, the planet's magnetic field helps protect people from some cosmic radiation. When Orion goes toward the moon, this protection becomes weaker. Orion is equipped with sensors, and the crew and mission control monitors space weather. Inside the spacecraft, there are areas where shelter is better, near supplies, equipment, water, dense materials. Sometimes it is a place in a cramped capsule where there is a little more mass between your body and space. The flight is short, the trajectory is calculated, the risk is analyzed in advance. But zero risk does not exist here, and the crew knows that better than any viewer. After the lunar flyby, Orion swings around the moon and begins the journey back. For the crew, another phase of tension begins. Now the most technically harsh part of the entire mission lies ahead: re-entry, returning into the atmosphere. And this is exactly the part that caused the most concern among viewers. Because Artemis I returned successfully, but its heat shield surprised engineers. In some areas, the material cracked and broke off in chunks. Not even controlled burning, but a more chaotic picture. For Artemis II, they chose a different path. The idea is to reduce the time spent in the conditions that led to the problematic behavior of the material. The price is a harsher slowdown. Now we are back where we started. The moon is behind, Earth is ahead. The spacecraft enters the atmosphere. First comes a light feeling of pull. Then the body begins to grow heavy. The G-force rises. Now down returns with force. The seat presses into the back. The straps cut into the suit. Breathing has to be more conscious. Outside, the light grows. Plasma wraps around the capsule. The windows no longer give a normal view of Earth. They become part of a fiery cocoon. Radio communication disappears for a while. This is one of the strongest psychological moments of any capsule mission. Mission control waits. The viewers wait. The heat shield takes the hit. The speed drops. The altitude decreases. Then the capsule slows below supersonic speeds. The small parachutes deploy. The jerk changes the movement of the spacecraft. After that, the main canopies open. Huge parachutes fill with air above the Pacific Ocean. The speed drops to a level where the capsule can hit the water and remain intact. But splashdown is not like a soft landing in a movie. It is an impact. The ocean takes the spacecraft roughly. The capsule rocks on the waves. Outside, ships and recovery teams are already approaching. Specialists enter the water, secure flotation elements, attach cables, and prepare Orion for lifting. And only when the hatch opens does the mission begin to feel like a return. Real air enters, not air cleaned by a system, not air pushed around by fans. Ordinary Earth air. After 10 days inside Orion, Even this can become an event. When the crew gets outside, the body does not immediately understand Earth again. The legs are weak. Balance is disrupted. The inner ear has to accept the world again, where there is up and down. People see smiles, cameras, teams, a ship, the ocean. But behind this moment is the whole chain that the viewer did not fully see. That is why Artemis II cannot be judged only by the question, they are not even landing on the moon? Landing is the next step. This flight answers a more basic question. Can we again send people to the moon and bring them back alive on a new spacecraft? If the answer is yes, Artemis III becomes not a fantasy, but a continuation. If the answer is no, everything else does not matter. The strangest thing about Artemis II is the scale. Space in reality is not like science fiction, where ships silently drift between worlds and heroes walk through spacious corridors. A real flight to the moon is 4 people strapped inside a machine built by thousands of engineers, and every bolt in it has to do its job. Artemis II does not open the door to the moon. Apollo already did that. Artemis II tests a different door, the door back, because in space exploration, the most important moment is not when the rocket goes up, and not when the moon appears in the window. The main moment comes later, when the hatch finally opens. And 4 people who lived for 10 days between Earth and the moon breathe the air of their planet again. That is why Artemis II became more than a test flight. It proved that humanity does not simply remember how to fly to the moon. It is learning how to return again. Subscribe, because the next chapter of space will be even more interesting.